we are going to learn how to factor a trinomial that has a number other than 1 as its leading coefficient. So we are factoring ax squared plus bx plus c. As you can see, we have a trinomial up here that is 2x squared minus 13x plus 6. There are a few different methods in order to factor this. I'm going to take you down a path that has some factor by grouping in it so that you don't have to guess and check how to do this. There is a process and it makes it much easier for you. Some students that I've taught before might call this the British method. So as we start this problem out, we have our two factors that we will need to multiply together, the 2 and the 6. And that means that you're multiplying a times c. So you're saying 2 times 6, which gives us 12. And we're looking at the factors of that product, just like we did when we were factoring with a leading coefficient of 1. And we are also looking for a sum that is equal to b. So we want our sum equal to b. Well, in this case, we have two numbers multiplied together, and all of our numbers up here give us a positive number. And we have one of our numbers, is our middle number up there is negative. So that means that we're going to need negatives on both of our numbers, and the one that adds up to be a negative 13 is actually the negative 1 and negative 12. Now what we're going to do here is we're going to write down the 2x squared, our first term, and then I'm going to write the two numbers that I was working with over here. I am going to make that 1x, that's a negative 1x, and a negative 12x, and then I'm going to write down my c term, the 6. Notice that these two terms added together give me that middle term of negative 13x. And what I've just done is created my polynomial so that I can start factoring by grouping. So what I'm going to do is I am going to look at just these first two terms and think, what do they have in common? What's their GCF? Well, I can pull an x out of each of them, and I'm left with 2x minus 1. You guys learned how to do that in 9.4. And then I am going to look at these next two terms and think, what can I pull out as a GCF between these two? And when I look at that, I think, oh, there's a 6 that could come out of both of those terms. But when I pull the number out, I want what's left to be the same as what I have here in my binomial already. So that means I need to pull out a negative 6. And so I'll be left with a 2x minus 1. And then notice that I have two binomials that look exactly alike. Well, what I'm going to do is I'm going to pull those two binomials out like a GCF. So I'm going to pull them away, and what I'm left with then is going to be the two numbers that are in front, and I'm going to create a binomial out of those as well. And I just created the factorization for 2x squared minus 13x plus 6. Go ahead and FOIL it. See if it works. 2x times x, 2x squared, 2x times negative 6, negative 12x, negative 1 times x, negative 1x, added together is negative 13x, negative 1 times negative 6, positive 6. It's the factoring by grouping that helps us, and we're going to go through several problems here to show you how to do this, and you might even want to watch this video again along the way. Let's do 4x squared minus 9x plus 5. So we're going to take 4 times 5, that gives us our 20. And when we work through that, I'll have 1 and 20, 2 and 10, or 4 and 5. Now, our sum is supposed to be a negative 9. The only way to get that negative 9 is if I put negatives on both of the numbers, and then my negative 4 and negative 5 will add together and give me that negative 9. So I'm going to start writing 4x squared minus 4x minus 5x plus 5. Again, notice these two middle terms add up to be that center term, negative 9. So I haven't made the polynomial any different. It's just written differently. So again, now we're going to pull a GCF out of these two terms. Look at what they have in common. Think yourself for a moment. 4 and x should come out front, and that leaves us with x minus 1. Remember how important it is to have that 1 there if you divide by the exact number that is in your polynomial that you're factoring. And then on the next set, we want to have x minus 1 left. How am I going to get an x left out of this thing? That means that I have to pull out a negative 5 so I can be left with a positive x, and taking a negative 5 out will leave me with a negative 1 there. So again, we are going to factor out what binomial they have in common, and that common binomial is x minus 1, and then what they have left over in front here gets to be our new binomial on this side, 4x minus 5. Our final answer is the x minus 1 and 4x minus 5. Now you might be asking yourself, what if I wrote the 5x first and the 4x second? Good question. Well, when I'm still looking at factoring those first two terms, I can take an x out of each of them, and I'm left with 4x minus 5. The other two terms, you look at that and you go, well, that's a negative 4x plus 5. If I pulled a negative 1 out, then I could have 4x minus 5. I have my binomials the same, so let's take that out. That gives me 4x minus 5, and I have my x and my minus 1 that are going to create my other binomial. And look, my answers are the same. The binomials can be in a different order. That's okay. It doesn't matter which way you put your two middle terms, because there will always be something that you can take out as a GCF. Let's look at 4n squared plus 11n minus 3. So this time we have 4 times a negative 3, which is a negative 12. Well, that's 1 times 12, 2 times 6, 3 times 4. But because I have a negative product, I know I need one of the numbers to be negative, and because I have a positive sum, I need that negative to be on the smaller number, so that when I add them together, I have a positive sum. And what will give me my positive 11 is that negative 1 and 12. So I'm going to write 4n squared minus 1n and plus 12n minus 3. Again, that negative 1n and 12n give me the positive 11n. Factor the first two terms. Whoops, I guess a 4 doesn't come out of there. Let's make it the right number. N comes out of there, which leaves us 4n minus 1. And you look at that other two terms, 12n minus 3, and 3 can come out of both of those. A positive 3 this time. And I have 4n minus 1. Again, we're going to factor out the common binomial and be left with n plus 3 as our other binomial. And we have our factorization. You guys are going to do so well at this because you're going to be able to factor without any guessing and checking. If you want to try this problem before me, pause your video right now. 2 times negative 7 is negative 14. So I'm looking at 1 and 14, or 2 and 7. And again, I need a positive sum, so I'm going to be putting the negative sign on the smaller number. And that means negative 1 and 14 are going to be my two numbers. So this time I'm going to do 2h squared. I'm going to flip it around. I'm going to make it plus 14h minus 1h minus 7, just to be different. When we factor these first two, I can take out a 2 and an h, and so that leaves me with an h plus 7. And on the next two terms, notice they're both negative. That means I should take out a negative 1 so that I'm left with h plus 7. Pull out the GCF of h plus 7 and be left with the other binomial of 2h minus 1. Let's try another one. If we have a negative leading coefficient, we don't like negative leading coefficients. I think we've talked about that before. So you will want to put your negative 1 on the outside, 3x squared plus 13x plus 4 on the inside, and just leave that negative 1 sitting out there. So let's multiply 3 and 4 together. That gives us 12. So I got 1 and 12, 2 and 6, and 3 and 4 as my sets of factors to work with. And the 1 and 12 actually add together and give me my 13. So what I'm going to do is I'm going to put this negative 1 on the outside, and I'm going to put down a bracket. And 3x squared plus my 1x plus 12x plus 4, close my bracket. And the reason I'm using a bracket right now is because I'm also going to be using parentheses in just a moment. So I am going to factor the GCF out of these first two. So no, 3 doesn't come out of there. What are you thinking? Let's take an x out and make that 3x plus 1. And let's take a 3. No, let's make that take out a 4. 3 wouldn't have worked. That leaves me a 3x plus 1. And I want to be able to tell the difference between my parentheses and my brackets. Now, inside the brackets, we're going to take out that 3x plus 1 as a common binomial factor. And we have the x plus 4. And then what we're going to do is we're just going to write that negative 1 on the outside so that we have all of this as our final answer. Let's look at this again. Taking out a negative 1, that leaves us 5m squared minus 6m plus 1. 5 times 1 is 5. That means I only have the factors of 1 and 5. But added together is not negative 6. But if they're both made negative, I get my negative 6. So I'm going to say negative 1, and my brackets, 5m squared minus m minus 5m plus 1, close my brackets. Negative 1 times, let's pull out our GCF, which is m. That'll be 5m minus 1. And I have negative 5m plus 1 here. If I pull out a negative 1, I can flip the signs on that so that I have the same binomial factor, 5m minus 1, and I have my m minus 1, the factors that are sitting in front, and then bring down that negative 1 on the outside and have this as our final answer. Another problem is negative 3x squared minus x plus 2. Let's pull that negative 1 out. Good practice here. Now, if you want to continue without me telling you what to do, go ahead and stop the video, do it yourself, and see if everything will work for you here. Okay. So 3 and negative 2 gives you negative 6. So we're looking at 1 and 6 and 2 and 3. But I want to add together and get a positive 1. So that means that I need my negative sign on the smaller number. So I end up with a positive number. Negative 1 times 3x squared plus 3x minus 2x minus 2. Notice how I kind of grouped them together so I could put some nice numbers together. I'm kind of stacking it for myself that way. So then I can take out my 3x and have x plus 1, take out a negative 2 and have x plus 1, pull out my common binomial of x plus 1 and my numbers that are left that create the other binomial, and then don't forget my negative 1 out front. And if you want, you can be a rebel and you can just say negative like that. I'll understand it to be a negative 1 as well. Just don't forget the negative. What if there's a GCF? Well, you should know the answer to this by now. Pull the GCF out. 12, 28, 16, what number? It's the biggest number that they can all be divided by. Well, I hope you're thinking 4. So we're going to write down 4, and then 3x squared plus 7x plus 4. Well, 3 times 4 is 12, and the factors of 12 are 1 and 12, 2 and 6, 3 and 4, and the only ones that add together and give me 7 are 3 and 4. So we're going to do 4 bracket 3x squared plus 3x plus 4x plus the 4. Take our factors out of this first one. That's a 3 and an x. That leaves us with x plus 1. Take out the 4 on the next set. Leaves us with x plus 1. And then I'm going to have 4 and x plus 1 and 3x plus 4 as my final answer. If you have questions, first thing, rewatch the video. Look through it again, starting from the beginning. Good luck on your homework. This should be able to help you with all of the assignments for 9.6. There isn't another video for it. These should take care of all of it. Good luck.